You're fine. Kabow! I said kabang. Okay. Actually, I think I hit the go live button.
Oh, hi guys.
Actually, no one's here yet, but that's funny. Let's see. This is a long description. I think everyone can see. This is going to be weird to explain. Constraints. A lot more constraints. Consist of any valid ASCII character. Hello, everyone. Hope everyone is doing well. Alright, so mapping question. Mapping A to E. That doesn't look that bad. Actually, I think I want this. Yeah. So we can try to get this all on one screen. Perfect. And constraints. I want that. There. I think we can see all this now. Boom. Given two strings S and T, determine if they are isomorphic. So I tried to look up isomorphic the other day, and I didn't really go very far. All right, let me let everyone know that we are here. I think this is public. Let me double check. Public. Yep. All right, let me put in at everyone. I can spell everyone. Ooh, I just had a little flicker of power. There we go. And Vinky sent something yesterday. What was that? Oh, that's the carrot character. All right, let me go back to the stream. Okay, so all right, we're looking at Leetcode 205 isomorphic strings. So given two strings S and T, determine if they are isomorphic. All right, so really don't know what isomorphic is, so we're just going to start looking at it. Looked up some math term, and it was like a cube and interdimensional and rotating and things like this. So all right, two strings S and T are isomorphic if characters I just added some words. If the characters in S can be replaced to get T. So that doesn't really explain anything. So when we get down to example one, all occurrences of characters must be replaced with another character while preserving the order of characters. No two characters may map to the same. So basically this is a variation of a cipher shuffle. No two characters may map to the same character, but a character may map to itself. So that's kind of what I'm thinking is we were to adjust that's kind of what, like a shift. I don't know exactly how we'll do this. So I had a couple of thoughts. I just kind of glanced at this last night and I tried to stop thinking about it. Nico, how are you doing? Can we do random video topics again? Talking about just, well, you give me a topic and I will see if, because I wanted to also be solving a problem. So I know we kind of talked about that yesterday. Because I know you brought up C-types, and it seems like you have a pretty good grasp on C-types. So I I don't know what you might need my help with. But, all right. So this seems like a cipher problem to me. So we're to take E and then we adjust over, or I'm thinking, because I know you may not see the benefit of this, but these problem solving skills are a higher level of order of magnitude than a topic video, because this goes into just raw problem solving, building up a catalog of how to go about presenting things. Topics or modules or libraries, in my opinion, this may differ from everyone else. You can go and read documentation of how to implement these things, but if you don't have a base case of, I did a video a long time ago about just because you know how to use a hammer doesn't mean you know how to build a house, because there's so many more intricacies that go into. We can go and buy all the expensive tools. Well, here's a perfect example. My parents hired somebody to do some work on a deck a couple months ago, and my parents gave them a lot of money up front. They went and bought all sorts of new tools, some really good stuff. Didn't do a very good job on the deck because their building blocks were very weak. Their methodologies, their measuring, their attention to detail. So having more tools is cool, but if you do not know how to implement them or use them, the tools are useless. If you don't know how to read a tape measure, the tools are useless. If you don't know how to iterate through something in an efficient manner, you don't understand the anatomy of an object that you're using. Things like that. So, and also I'm trying to stay sharp with my problem solving skills. So I'm trying to do two things at one time, because I don't have a lot of time left over after this to be staying skilled, because I need to keep my skills sharp. So when I get a technical interview, I have to be aware. So I'm doing this, and then while I'm doing that, I'm just happen to be live streaming. So it's what I'm doing, and then I'm hoping somebody else gets something out of it. So that's the reason for these streams. So, all right. Oh, is that your pixel thing? That's very cool, Nico. I like it. All right, let's go back to chat, make sure I haven't missed anything. All right, so basically what this is saying is that, and is it off by the same? Let's see if this is what I think it is. Was it ORD E 101 ORD? Here, let's go back. (101) A equals ORD A 97. So 101 minus 97, 4. Okay, so that technique is not going to work because those are separated by, I believe, 5. So we have, let's go back over here. New. So if you are new here, thank you for joining us. A, B, C, D, E. 1, 2, 3, 4, 5. E to A. Okay, so then G to D. Let's see if that's the same thing. D equals OR. So what I'm doing is I'm trying to see if this is Vinky. Hello, good day to you. Thank you for joining us as always. So, I have not put in. I may have it in the description, but I don't believe I put it in the chat. So here's this. Let me check and make sure. What is it ending in? Isomorphic string. I actually have it directly into the. Yeah, okay. I do have it in the description. Excuse me. So, apologies, everyone. Maybe I'll mute my mic and cough really good. So the isomorphic challenge basically, so we have we have the repeat characters. So E, G, G, A, D, D. I'm trying to see if it's a shifted cipher. I can't remember if it's called a Caesar cipher, but it was basically you take the alphabet and you shift it over a few characters and then you write, because this would be like, okay, I don't know what word this is, but it would represent something like this. So each character is shifted over. So if it's a D, it repeats itself. Where then this is isomorphic. This is not, because it is one character, then two different characters instead of the same character. Hang on, I may need to go let a dog in. We have 3 dogs and they all have different personalities. So all right, let me see if I can finish this. Oops. Finger's not on the right spot. D is 100, and then what is G? Or D, G, 103. So see, that is already, so it's a different gap. So, all right, I have no idea exactly how we're going to do this, because this may be, we may need Venki to the rescue with some good math skills here. I don't know exactly how this might be. So the G is shifted 4, or the E is shifted 4, but the G is shifted 3. So D minus G -3. Let's go the other way. G minus D 3, where E minus A was 4. So all right, that's not going to work. So it's more of patterns. I don't know. Let's because look, here's an example, and I know I'm probably not explaining this very well, but paper. So paper and title, they're the same, because the first letter, so the first letter appears, so we can't use count because they have to be in the exact same order. So not just number of occurrences, but they have to be in the exact same order. So P is the first character and the third character. Title, first, third, then there. All right. So not really sure. Okay, constraint. Let's look at constraints too before we get too far out in the open. Whoa. I know isotopes and isomers. Isomers are like identical. Isomers, I guess. I don't know. Isotopes, I always thought is isotopes is a variation of an element, its average element, or its I can see it in my head, but I struggle with explaining it. And I don't know if it's an extra neutron or if it's an extra proton. But it's an isotope is a variation of an element that occur, because you have the atomic number, that's how many neutrons it has, and then same number of protons but different number of neutrons. Bingo. Okay, there you go. Because I've been reading about making of the bomb and how they were stumbling into and learning about the nuclear physics and learning about what was coming out when they bombarded with protons and positrons and neutrons, and then the releasing of the energy, and how they basically discovered and invented the calculations for half-life. I don't know. All of it is very, very interesting to me. So, all right, the constraints are between 1 and whatever that is. So that's 520. Could be up to 520 for the length. And they are the same length. Okay. Consists of any valid ASCII character. So yes. All right. So they are using they're basically hinting. So this is an ASCII problem. I don't know if you would agree, Venki. But hey, everyone do me a favor and hit the like button if you've not done that already. I don't know how today's stream will go because I don't know. I'm not sick, but I don't feel the best right now. So we'll put in the old effort here and see how it goes. So, mapping. I know I've built something with the map function, but I don't default to it and go, oh, I know exactly how to use mapping. So I don't know if, let's just take a peek at it. Dir map. Help map. Let's get into help. And map. All right, so make an iterator that computes the function using arguments from each of the iterables. Stop when the shortest iterable is exhausted. Well, that's not very helpful. All right. And let's get out of there. So let's see if we can just solve this human brain, because I'm not going to lie. The one that Venki solved for everyone, I could not get my human brain to get around and design an algorithm. So definitely not. If you can't design it with a human brain, you're definitely not going to be able to write it in a programming language. So it's vital. So it's vital to get it down first. So all right. So egg is, so because we don't have the constraint of, so how do we deduce? So how am I deducing that this works? Because this is one letter and these are two letters. But what am I actually doing? So what am I actually, how about dictionary and zip? Okay. Let's throw that against the wall and let's see what we get. I like that we're going to start there. So we're going to zip the two of them together. Cool. All right. Dict zip. Let's bring two of them in first. Is that that doesn't look, how is this legal? Yeah, I didn't think that was legal. Like, why is that not throwing a syntax error? All right, S and T. There we go. All right. So it really doesn't matter, S and T. Run this. So if you're super new and you've never seen this before, we're taking a zip object. We're putting these together. Think about a zipper, how it lines up. So now Uh, no way. No way. Is that what you had in mind? Because I had no idea it was going to work that way. Because I was like, wait a minute, that's going to be a key value. But so it's going through. That was very cool. I was not expecting that as the creation. So just kind of let's go through here. What this did is, and again, I made the comment about understanding the anatomy of an object that you're going to be using. And sorry, I'm kind of blanking on this for a minute, and I'm kind of blown away. But basically, so since there's already a G in here, you can't have two keys of the same. So as you're going through this, here's the functionality or the anatomy. I don't know if that's the best term, but I'm really hung up on this because there's some levels of really senior and architecture kind of work that we've seen that individuals write, and their understanding of what an object and how it interacts and how it is designed to work. And you can use that and leverage that to your advantage to facilitate the problem that you're trying to solve, to take some shortcuts that our brain is doing, and now we're going to utilize those tools and those abilities that Python has and help us. So, all right. So now, all right, I like this. So basically, we've mapped this together, and so we map this together, or we zip this together. Oh, this is kind of cool. I was not expecting this. All right, Venki, this is brilliant. So now watch, and let's see if. So we've built this. We've put it together. For I in S. So is it S equal to T? Comparing T to S. So then we map it. All right. Venki's probably already got. All right. What am I doing? New equals here. Then we'll try it on this other one. But this is a brilliant solve, Venki. I love this. I would have never thought about this, but I like it. I like it a lot. All right. So for I in S, then hang on. So what I'm trying to do is, as we go through D, I, new, there we go, and then print new equivalent to S. Think I did that right, and I'll go over what I did in just a second. All right, so I did something that I wasn't expecting. So because this looks like this mapped right. So for E is T. Okay, so all right. So this is what I'm envisioning. I'm going to iterate through. So T is, so for I in S, print I, right? E-G-G-G. Okay. So then D-I. Why didn't this work? Okay, so what did I miss? Because that's ADD. So new is add. Ooh, the other way around. The other way around. Here we go. TS. Key air E wet. All right. Okay, what am I missing? All right, let's start over. So what I'm envisioning is, as we're going through and we're mapping this, I don't know if technically this is mapping, but we've zipped this and put it in a dictionary, and we're referencing a key value pair. So Venki had if you're just joining us, Venki had a fantastic solution to zip this and go through. And why is E coming out when we do this? Because again, that's not what I'm expecting. E. Okay. Let's comment this out. Print D I. Line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. D. A to E, D. A to E, D. For I in S, print I. Let's just make sure I'm working this right. There we go. There we go. And there we go. Okay. All right. So with a lot of problem solving from Venki, is this what you got, Venki? So Venki had because I was not expecting this to happen. So now let's do this one. So now we should get false. And okay, so why is that true? T S new is foo, because this should map all right, because I just mapped okay, so this is still the wrong way. Or is this T? So now this is where my brain struggles. All right. So I've mapped O. I think I changed both and went back the wrong way. All right, so let's dissect this down. So, Nico, I don't know if you're here, but this is a perfect example. So even though we have the tool and we are using this tool in a new variety of a way, implementing it is, now granted, there may be some of you who have already done this and like, I don't know why this is having a hard time for him, but the reason why really for these streams, well, one, to keep me problem solving, but two, if anybody can gain any comfort level from watching somebody who's been programming for 11 years, watching the struggles that they go through with actually thinking through a problem live and being okay with it. Because this isn't, I mean, I've gotten more comfortable with it, but, and also me kind of getting used to being in meetings and virtual meetings and things like that. So, all right. Yeah, okay. So I just wanted to share about, I just found out that. Oh, found out what? I'm thinking to track the item like F linked to B, then 0 to A, then the next one can be O, not B linked, since mapping. Windows command doesn't actually scroll its content. Oh, I did not know that. But Venki, scrolls the pixels inside the terminal. That's kind of cool. I think we're really close here, and I'm just the order of these. Because when we do it this way, FB, there we go. So, all right. Because we want to see if this, I think Nico sent something else. Let's take a picture. Let's take a look. Okay. All right. So when I get, because this is what this will throw up, because when I have an O, I should get, it doesn't matter, but if I get an, whatever it is, because then S. Bingo. All right, now let's make sure this one worked. Okay. They can't both be false and both be true. So I'm not thinking about this right, because it's mapping, not mapping. I don't want to use the word. We're we're associating. Associating key dictionary is an association of key value pairs. Mapping is mapping, and I only used it a handful of times, so I don't want to misuse mapping. So I'll stay away from mapping. But Venki, I think, has a solution. Venki, if you can do it with mapping and you really understand mapping, try that, do that. I feel that I'm really close here, and I'm not utilizing the tool properly. Feel very comfortable. And I know it's either going to be one of two things with me. A transmutation, I'm having these point back and forth the wrong way, either wrong order, or I'm going through it wrong, or order of operations. That tends to be where I struggle. So, all right, so if we have an E, this will be right. why is this throwing an error? Because I key value, okay, because S, so I do need to change this around. Okay, true. Okay. All right. Eggs and add is true. This is false, but we get true. All right. That doesn't make any sense to the structure of this, because if I have B iterating through, I get, because I'm comparing S to T. So for I in T, print I. All right, right? Boom. And now I want to test because I have okay. Now this is false. Okay, because B is not in. Oh. This is right. Because it's not in there. That's what I'm missing. All right, so let me. I'm thinking that it's broken. But of course, if and I don't know if it's not true. Okay. That's it. So I'm freaking out because B isn't in here, and of course B should not be in here because I'm trying to look for something that doesn't exist. And if it doesn't exist, it isn't a match. So let's go. All right. If try accept pass print false. False. And shouldn't be that many. Break. False. Let's see where B is. All right. We want to make sure we're heading in the right direction. So basically, I want to reference because so I'm wanting to point. Let's do a visual. can I copy this and put this? I've never tried this before. Let's try this. Text box. Is that the text box? No. Text box. Cool. Okay. All right. So here we are. So here's our key value. Let's get rid of this. That is a sad little eraser. There. Delete. Move this up here. Perfect. All right. I like it. All right. So we have S and T. Then we need a temporary variable, or I think we do. Everyone can kind of think on their own and be like, no, we didn't have to do a temporary variable, so we can go from there. So right now we have this mapping S to T. S to T. So S and then T is bar, and then the dictionary. So F is associated with B. O is associated with, as you can see, you can only have one key and value, R and R. So what I'm expecting this to do, what I'm trying to iterate to do, is have F be looked at, and then do B, then have O looked at and return R and R. This is what I'm trying. Dax, good morning. How are you? We're looking at an isomorphic challenge. It's in chat and it's in the Discord. Or it's in chat and in the description. Never done anything like this. Vinky had a very good solution, or a very good starting point, and I'm just misutilizing it. So I'm attempting to iterate through, and my goal is to, because I think this is the way we need to do it, and I'm trying to have BRR come out because we've associated the letters. So it's not a true cipher shift, because we checked egg and add. So this is true because they have the same pattern. So E is used once, A is used once, G is used twice and they're consecutive, D is used twice and consecutive. So Vinky's solution was, let's throw it in a dictionary. Let's use zip in a dictionary. So I did that, and we're super close, but I'm just not getting this output. So we've tried a variety of things. This is garbage, so we're probably about to start over. So let's just start over. All right. Print I. Bar. So now print D I. I do not get why that's what I wanted. There we go. All right. And then this should be egg. No. Okay. Seriously. Okay, now all right. new. Again, I was going the wrong way, and I knew what the probable problem was. All right, and then adding this. So I'm rebuilding it, and I'll go through this in a minute. And then now let's look at this one. So I was rebuilding it and checking it against its. Okay, here we go. So let's take a peek at what I was attempting to do. And I was doing it. So Vinky, thank you so much for putting us on this path. So let's dissect what in the world am I actually doing. So with Vinky's real true problem solve here, we're associating these characters. And we're doing, let's print D. Let's look at this. Oh, you stepped away? All right. Well, we have it with your outstanding basically problem solve here. So we associated these letters to each other. So it works if they are repeated and they are linked, because we're going to link E and A, G and D, and as you can see, since they are repeating, it doesn't matter. So every time we have it again, now when we do this, you're going to see we have another problem. Or it's going to be associated, because you can't have multiple keys. You can have a key point to two different keys point to the same value. You cannot have two different values point to the same key. If that makes sense. So as you can see, since it's zipping like a zipper goes right, left, right, left, right, left, right, left, it goes back and forth. So the last time O is associated, it's associated with an R. So what I was doing incorrectly is we're basically testing to rebuild T. So I'm using the key of the S characters, and then rebuilding T to see if it's the same word. So as I did here when I was manually going through it, I wanted it to be BRR, because if it was really like foo and its characters, it would be either both R's or both A's. So as I come through, so I'm iterating back through S, because this is our base case, and I'm rebuilding T. So I'm checking, and I took a temporary variable with an empty string, and then I'm incrementing it with the key value association. And then I'm checking to see if the new is exactly like this, because if it's associated the same, it will spell the exact same word. If it's not, it will spell a different word like this. So all right, let's throw this into Leetcode and see. And this seems pretty quick because we're using zip and dictionary, which are pretty fast, and then we're only iterating through the string one time, but then we're doing a comparison. So 1, 2, we're touching this a couple of times, but we're utilizing some built-ins that are pretty fast. All right, let's throw this in here. How long have we been on? 51 minutes. Okay. Then I got to get some yard work before the rain comes in today. Sorry. There we are. Boom. Okay, so we need all of this. We can comment that out. Comment that out here. And there we go. All right. So Vinky always don't need that either. Missed one. And Vinky always comes to save the day. And 1, 2. Test this solution. Let's see. Is this your... Okay. This is failing. You're sending me some stuff? Let's see. Alright, Lynn, ISO, temp. If you're not on Discord, you're missing out on all the cool stuff that Venki sends us that Venki solves. Okay. Temp, dictionary. Got it. Lynn S, return false. We did in the constraints, we do know that they will be the same. So just if you want to take that out, we don't have to test that, but that is very thorough. That is extremely thorough. All right, so for C and S zip, then you're checking to see if they are the same as we're going through. Right? Okay, so let's look and see. So let's also take a peek at this. So let's come down here. So for I in zip st. Oh, okay. Yeah, I and J. So you can unpack. So here, let's go back for a second. Let's talk about unpacking. So I'm going to assume, I always try to assume that we have very new individuals here. So just in case you're super, super new, let's go through print I. We're going to do a little bit of an unpacking exercise here. I'm not going to do that. Comment that out. So we're going to look at this. All right. So I guess maybe I'm not thinking about this right. So for temp C, so you created a temp dictionary. All right, so for C, and let's move this over so everyone can see what I'm trying to envision. All right, I think that's pretty fair size. How is it bigger? All right, I think everyone can see that. Yeah, that's not too bad. So all right, here's Venki's solution. Let's kind of unpack this. So for so we're zipping an object. So we're unpacking here. So what I was gonna show, and I got distracted. So when you create a zip object, Python, it's a zip object, and you can then iterate through it or unpack. Then you can unpack this further. So you can really have the experience with this. When you do this, it creates a zip object. You can't really see the contents of it. You need to turn it into a dictionary or a list. But you can also do this right here. Iterate through it like so. Now, here's something that is also very important. It took me a while to get this. So there was a contents, let's do this, list so you can see this. Zip S and T. So I'm putting this into a list so I can kind of see it. So it's a list of 3 tuples, and then inside the tuple, 2 strings. So the first time we did this, we got this. Now I'm adding a second character because I'm iterating through this object, which is here, which is basically the equivalent of this. So now I'm unpacking it some more. I'm saying, hey, I'm passing you two characters, 2 temporary variables instead of 1. And actually, we're going to look at that in just a second of what I almost did, and to really drive this home. So now F and B, oops, didn't want to do that. So now what happens if I accidentally didn't add J? Because this is how this is what actually cemented this and how I actually really learned this. I was like, wait a minute. What happened? I called because I unpacked it, and the first object inside the double object is I, and the F. It's that column. So all right. So let's go back. All right. So if C1 in temp, if temp C1 not equal to C, return false. Nice. Hang on, what is on my... Sorry. I like that. And then at the end of the for loop, well, I don't want to say. You keep working on that and you solve it, because right now I'm not getting a right answer. So let me show you. Let me put this back. So mine, this is not working for me. Let's see what I missed. I'm even not on chat, so I can't see. All right. I didn't return anything. Hang on. Return. Return new equal to t. There we go. Let's see if this solves it. Egg, foo, and the third one. The third one is title. Oh, we didn't even check this. We had this great example here. And then we'll see how the time complexity is working. True. Awesome. All right. So now let's run it. We got our standard. Got a wrong answer. S&T add use case. Copy. Paste. S and T equals. All right. So now why is this? Because they found and exploited the problem, and this is also why I really like Leetcode, is because you're not going to get away with sloppy code or a sloppy fix, because you will get tested on an edge case. And okay, B is B, A is A, D is B. So, there we are. So now what I'm thinking is, well, one, I'm thinking Venke's solution is great, because I think Venke was very, very close. So the problem that they're exploiting, so it's what I'm doing, and I'm double checking. I'm rebuilding. All right, so I have a flawed technique in human knowledge, in human decision, and then I wrote it exactly the same way, and they found one that works around it. So, all right. Let me, because I can't. So if it's a B, return a B. A, return a print new. I want to print this out. So Y. Yep. Because if I have a double character on the other side, we have a problem. But when we have a double character on the front side, it catches it. And there's 46 cases, and I got to 39. All right, so we've got to. So why does human brain look at that and go, that's not the same? Because B. Because it's not failing on the A. Or is it failing on the A? Why am I getting the same word? I think it's because the values are the same, but the keys are not. And I wonder if I go the other way, it would fail because of this, right? I think we may need to abandon this and go back to Venki's solution. I think Venki's solution is going to be, we could tweak this. Sorry, there's a lot of hard and fast rules, meaning there's rigid rules. If this happens, do this. Now, we're going to talk about a very soft rule right here. And this is the delicate dance of just practice and experience. We could, I don't know what the answer is right here. We could sit and try to make this one work or abandon it. So there is no 100% do this all the time. And Dax could probably speak to this as well. Hi, mister. How are you? Glad to have you here. Don't know if this is your first live stream, but this is the first time I believe I've seen you. I've started learning Python. That's awesome. We are glad to have you here. You're in the right place. So we're looking at a problem right now. If you're just starting, this may be really, really weird, but we're going to walk through a lot of stuff right now. And actually, we're going to kind of talk about a more further along task, but everybody deals with it. Everyone deals with this in their journey. So what I'm going to talk about, practice, just practice. Begin to understand the syntax, and then kind of what we're doing right now is I've been programming and using Python for 11 years, and I think only these challenges, online challenges, are things that I haven't been able to solve because they're really good edge case testing. But what we're discussing right now is when to abandon a approach and start over. So this isn't a tip. This is more of begin to learn yourself. So when you're designing an algorithm, you want it to work. You want it to capture 95% of the problem. You don't want to start with solving the 5 remainder. You want to solve the first 95, the big bucket, and then try to tweak it. Now, we're at a crossroads right now where we have an algorithm. We're using this off Leetcode. You can look in chat, scroll up. Actually, I think it's still in view, or over in the description down below, and the Discord. Make sure you're joining the Discord because so you can get all the support you need and deserve. Ask any questions, post code, just anything you're working on, or abandon and start over. Because right now my solution, we've gone kind of circular on it, and we're not making any progress. But one of our members and viewers is probably closer with a solution, so we may be abandoning this and going and using their approach. So this may look really weird, but play around with it and read up on zip and dictionaries. And if you have any questions, just holler, raise your hand, say, I don't know what this is doing, but this is a very powerful tool in Python. And if you use it properly, it can really help you solve some things. So, all right. But the key to getting better at anything is just practice. And I just heard a new guy at a tournament yesterday for jiu-jitsu. And he's a young guy, and he just wants to improve. And he was talking with one of the older guys. And he's like, just tell me what I need to do. Just tell me what. And there's no shortcut. There's no shortcut to any of this. You just have to practice. It's with everything. If you want to be good at anything, you just have to practice. No, I'm not a pro. I like what I'm doing. So it's just like anything else. No, guys who are pros have been programming and doing this for 20, 30 years. Now those individuals can really write some elegant code and solve some really banana stuff. So all right, Venky, did you get yours? Did you get yours done? Because that's so close. I want to see if I can get this to work, because this is so close with your solution. And I just need to tweak it, because I don't see. But if we do it here, because if I associate this, all right, so the main issue, if I'm understanding this right, because it's a directional problem. So with dictionaries, to give you an idea, dictionary is what's called a key value pair. You have information and you associate, this is the key, and you associate a value to it. So the reason why these are so utilized so much is because they're very, very fast in Python and in programming. So you pull this up and you go and get this information, and it's just really fast. And it's it just helps you associate things. All right. So if we look, we would have two values for O, and here we have two values for B and two values for A. So that's why, and it's the reverse. So directionally, so what I'm saying directionally is I built this and said we're going to reference here and look at this, build this, and go backwards. Venky, here's me throwing something against the wall. Could we do a dictionary of both? And whoever has the smaller dictionary, we look the other way. So, all right. So in this one, this is wrong because this dictionary wait a second. We wouldn't have to check. We do two dictionaries and they associate each other. So then, all right, so this has len of 4. Yeah, remember I was saying I used 2 hash maps and checked the same elements? Is that... Okay, yeah. So we were to make 2 dictionaries, and if they're not the same length, that might be too fast. Because, all right, so this is true and this is wrong, but if we comment these out, comment this out, then we do this. This is true. D1, D2, D1, D2. It can't be this simple. And this is, okay, everyone, we'll talk about this in a second. D1, D2. No way. No way. No freaking way. All right, so here's... This is an example of... This is an example... Should this, Venky, should this work? We're going to try this. So this is an example, pure example. And this is, I stumbled across this. Look, I can write some really good code and I can write some garbage code. So do not, but it has everything to do with, do you understand the problem? Do you really understand the problem? Let's check and see this. This can't be. Okay, that does not solve it. False, return false. Why? Didn't we just get this to return true? Oh, sorry. I dropped the len. Holy moly. So we'll go over this in just a second. Okay, so we have one more. All right. Oh, that was going to be so cool if that's it. Well, guess what? They found another one. All right. Okay. And T. Yep. Check this garbage out. So now they've made it where it's exactly the same. Okay. All right. So BAAB, BAA. This is why I love Leetcode, is because, all right, so Venky, how close are you to your solution? Because I think you were really close. I was trying to make this as elegant and so all right, everyone. So what I was trying to do here is everything. So, Mister, I don't know if you're still here, but I'm going to speak as if you are. So, the ugly truth in programming is you have to pick a starting point and a reference point. So what I'm doing is I'm picking, when I originally did this, I was picking, we're going to look from here to here. And then we're going to double check against this. Well, that was working if this would be a reused letter. Now, since I'm looking in one direction, this fails because this has double letters here, but not double letters the direction I'm looking. So I can't see behind me. So for a second, I go, all right, because I wanted to look backwards and look both directions. So I was making a dictionary to compare this to this, and I was making a dictionary to compare this to this. And my first guess was, wait a second. If we look back and forth, if they're going to reference each other, they should be the exact same length. So that solved this problem and this problem. But if you look right here, it associates B to A, B to A, B to A to B, A to B, A to B. So and then B to B. So this is why this fails. Right there and right. So it's perfect, 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 except for B to A and A to A. Yeah, because, and does this even have the same length? Because also, side note, if you think you could just count the characters, they have to be in sequence too. So this is wrong because B, can I replace all A's with B's? No, because here, right up to here, you're good, except when you get to the end here, it falls apart. So, all right, let me go and look at chat and see if anybody has any questions. All right. So I threw this against the wall and it broke. So I think we need to check and use whichever is smaller. Then we iterate and we change this. So how did I determine that? So basically, whatever the smaller one is, compare it backwards. So it would catch both of these. And then if they're the exact same length, it wouldn't matter which direction you look. You can take either. So if I take, because like I said, here, if I take G and I look forward with A, it's fine. But then if I switch these, B and G, G and D. Okay, all right. Let me see if I can get this out of my head. So if D1 is shorter, look this way. Well, one, if they're not equal, it's false right off the bat. Okay, there we go. If they're not equal, false. Else, B to B, because I would get B to A. So now I want to look at this. So D1, look at that, and D2. All right. So if they are the same, then we're going to, there we go. If they're the same length, we need to build. If they're not, false. All right. All right, let's get this into a function so we can at least have this be right. All right. Same def, so I can at least get the S and T. Okay. There. Move this over. Okay, if copy not equal, they're not equal, boom, it's just blatantly false. They have to return false. Okay. All right. Else what? What in the world just happened? Okay. My inside return same ST. And we're back to this. So keyword B, so D, so it would have thrown up on what? Return new equals. We may need to tweak that a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. DI. Did I not make... I made the dictionary. D1. Oh, crap. Which way are we going to go? D1. Okay. So I changed the variables a little bit. All right, let's go through what I just did. Let's flip these around and make sure that this will work the other way. And what I mean by that is, because this is directional, so key value association. So we learned that when we have a double letter and a double letter, but here we're talking about this. When we have a double letter and we're looking from S to T, this would fail because our key is a double letter. We're going to lose. But we had a problem when we're here with a double letter and we're looking backwards. So we're trying to decide and solve which one is which. So now we're going to test this, and this is also false. So maybe. So let's go through what in the world I'm doing here. So if we have a double value in either use, so double value, because right here, a G and a D. So we have a double value, a double use of a character, double use of a character. So they need to be the exact same character. Now, this way, double use of a character, it's on the value side. So we had a problem. So what dawned on me was I was like, okay, if we are going to be looking back and forth, a double value and a double value. So the key here would be we'd have 2 keys, 2 values. But if we were to look backwards, we would have 3 keys, 3 values with 2 double values. So it really depends on which direction you're looking and associating. And that's a key fundamental basic of programming. So what dawned on me is, well, the dictionaries have to be the same length if they're going to be, if this is going to work. So I was like, wait a minute. Is it this basic that we just test the lengths? Well, then we had this right here. But so automatically, we don't have to check. We don't even have to iterate through anything. We make 2 dictionaries. We have them look back and forth. We have them compare each other. We take the S, compare it to T, and we take T and we compare it to S. Well, if they're not the same, if they're not associating each other with the same character, they will not be the same length. So this is just blatant 95% of the buckets, right? 95% of the answers. Boom. Now we're going to tweak this, and we're going to look at, very specifically, we're going to look at one dictionary and build. So I'm taking D1, which is our primer S, and I wanted to make sure it would check and fail both directions, and it does because they're the same. The dictionaries are the same length. It is a problem. This blatant test does not work if the dictionaries are 2 different lengths. So we saw that earlier. It caught this loop only works in one direction because this has a key. Because right now, because what we were doing is we were only looking at one dictionary. That was going to have 2 keys, where then this would have 3 keys, and we could still rebuild this T string. So, all right. So now let's throw this in and see what we get. Let's see if this works. Venki, have you done this solve yet? You may have already told me, so I apologize. All right, let me make sure all the prints are commented out or deleted. Delete. Indentation. Because Leetcode does not do a very good job of pasting. Okay, past. Case 1, case 2, case 3, case 4. All right, here we go. And boom. It is very slow, but it works. So let's talk about that for a minute. So what do you mean it's slow? So, all right. So there's levels of programming. Get it to work. Get it to solve your problem. Now, when you get into areas where things are very complex and very costly and very large, well, very large. Let's just talk about that. So I'm on the back side of this. I'm only faster than 20%. So there we go. Oops. Not spill my drink. I could have sworn the erase worked. There we go. Let's see. So my solution is right here, 49 milliseconds. So if you were to extrapolate this out, I'm in the bottom 80 percentile, which is not great. I mean, I'm not even midpoint. Now, if you can see, I'm 10 to 20% off. So the midpoint is 40, so 40, 41, 42. So the midpoint is 42 milliseconds, so I'm off by 9, so I'm off by about 20%. So 20% gets me to midway. But let's kind of take a peek. Venki, did you have a solve for this? And Venki's solutions are very, very fast. We looked at one of Venki's the other day, and it was like 8 milliseconds, and the average was like 30. So I mean, almost 4 times as fast. So all right, how long have we been on? We've been on an hour and a half. So we may, let's see. And there we go. I did not hear the beep. I wonder. Okay. So return. How fast was yours? So okay, Venki agreed with. Okay, so taking return false. So for C in D1, if C D1 not index. Ooh, I like that. So all right, so let's pull this over. How fast was this? So what Venki is doing, and if you're super new to Python, I think that's that. So all right, whatever you're doing to the sizes that you're cutting are perfect now, because then I don't have to pull it up and I pull it from the other monitor and it stays associated. So that's perfect. So all right. So let's kind of read through this. And reading code is really weird. And again, if you're still really new and you're like, oh, wow, I get this. Yeah, that's great. But I remember like reading the number triangles. I'd be like, oh, this makes perfect sense. Well, yeah, because you're reading it. But being able to then go and recreate it. So what I want you to try to do, collection counter water. Nice. So T, water. Yep. I like it. Yes. So, all right. Collections. Collections, if you're super new, collections are a built-in module inside of Python. Python has so many built-ins that you can import. And then there's even more that are outside that you can install with pip. It's a installation package. Is pip considered a package? Because I think it is, because it's got a pip file. So yeah. Oh, and Nico, were you able to get NumPy working on your machine? Just a side note. So all right, let's go back to. Well, that even comes in even more. All right, so let's go back to this. So if the two dictionaries are not the same, boom, just throw it out. We automatically know that it is false because they have to be the exact same length, because you can't have different associations. All right, for C and D1, so we're iterating through D1. You're getting the key. So when you iterate through a dictionary, here. So when you for key, this in D print key. You only get the keys. And you might say, but I typed key, so that was a bad example. You only get the key. Now, if I wanted the dictionary, then it would be something like this. Then I take the dictionary, and if you don't know how to associate this, we'll do this in a minute. So now I get the value. So this is the association. I have dictionary. Then you pass in a key inside square brackets. I know this looks weird, but once you practice this enough and you get used to it, you know, hey, this is how I practice in things. So this is my key. I pass in my key, putting the key into the dictionary, the lock, and I turn the lock, and I get the contents. I get the value. Now, don't just think it's a string. I can associate anything to my key. Why didn't that work? Because I wanted to put a dictionary inside unhashable item list. That shouldn't be a syntax error. Well, I shouldn't say that. There you go. Shouldn't have expected. I'll have to think about that. So I associated an empty list to my key E by this assignment. All right. Can't fathom why that was illegal, but that is illegal right now because, I mean, I've had dictionaries as values, so my syntax is a little off, but I knew that would work. Or I've recalled using this syntax, and it's proper. It's a legal statement. So you'll hear legal statement, illegal statement. So right now, this is an illegal statement, and I'm not recalling why. So, all right, let's go back to chat, see if there's anybody. Okay. What does counter do? I still want to get. I want to get hung around. Default dictionary. Like if you have many words to count in a dictionary, you add it like. Yes, counter reduces it all down to one line. Yes, so counter. Well, here, let's take a peek at it. And Ineon, I think I've seen you before, so if I haven't, glad to have you here. And if you have been here before and I've said hey, glad to have you back. So let's import. So this is how you do it if you didn't look in. Import collections. Dir on collections. All right. So collections is, boom. It is, let's just do help on, let's bring this in. Collections, yeah. All right. Yeah. So if you've not used this help prompt, you get a little bit, you get a touch more than the normal help. So what does collections do? It's too much. All right. So counter. Let's see if collections counter. Yeah. All right. So what is? I am really hungry today. So all right. Give you an idea. Basically creates a. We'll do this in a dictionary really quickly, and because we cheated here a little bit and threw this in a dictionary really quickly. But here, let's draw your eyes to this right here. So counter we're going to take our counter. We're going to pass it in a string. It's now associated with. Let's bring this down here because they're doing even more. So, all right. And if you've not seen this type of import, so we don't have to type all that from, what was it? Collections, import, hello counter. All right. So what I'm doing is I'm saving memory. I'm saying, hey, go look in this module and bring me this. I don't need the whole module. I just need counter. So C equals counter AABBB. C. So all right, it's going to do this for you very quickly and count all the characters. So let's take a peek at this. So if I were to take my string AABBB, so I could do this. Venki, have you seen a dictionary comprehension? I would have to remind myself how to do it, and I made you go pull up code, but dictionary comprehensions, same technique. So all right, Ineon, here we go. So I'm going to make a blank dictionary, an empty dictionary. So for I in X, if D I think this is a legal statement. I haven't done it in a while, but I'm trying to show a variety because I think that's true, because if it's present, then D I increment 1 else di equals 1. Yep, okay. If I in D. So what I'm doing, let's go over this. All right, so same thing with our counter. Same answer. So let's kind of go through what we're doing here. So I don't know if you were here with the dictionary and it testing. So right now D is, let's just put this in here. We just overrode everything. So D is an empty string. So I'm iterating through X. So the first time value, len value for value in my list. Never used it though. It's an interesting, and it looks weird. I didn't know, with you being very savvy with list comprehension, if you also defaulted to dictionary comprehension, because I still have to draw this out. So all right, Enion. So let's look. So I'm standard header. I'm going to iterate through a sequence, and this sequence happens to be a string. So now what I'm doing is, I like to do it this way so I don't have to think about it, because you're going to have trues and falses, and that messes with my brain still to this day. Hated them in school, hated them on tests. So is it present? Have I already, basically what this question is if you're still super new, when this dawned on me, is this true? Is I in D? Well, the first time through, D is an empty list, or D is an empty dictionary. So right now, the first time through, nothing is in it. So this isn't going to be, so it's automatically going to go here. So I'm going to take, so the first time through, it's empty. So I'm going to now go the first A in D, false. So that means this is going to happen. So then I'm going to take D, and I'm going to setting it equal to 1. So it's our first time in. I'm setting this equal to 1. So now D is a dictionary of one key, 1, and its value and this is why having association, its value is 1. Key, this side of the colon is the key. Come on. This side of the colon is the value. So now the second time through is A. So right now let's go A in D. Now it's true. So now the second time through, and I don't know, have you seen incrementation? This is the same as, so y equals 1, y equals y plus 1. Now, so y is now 2, and this is the shorthand. You're going to learn programmers are very lazy, and shorthand gets invented all the time. So this is the exact same, this is an equivalent of this. So if you look at it, I'm going to compress this, move this to this side, I'm adding up, I'm incrementing up, I'm associating. So way you want to read this is I'm associating adding 1 to this value, because I'm reassigning this in a very quick manner. Cool, thanks for the explanation, but why are you using dictionaries? Can't you use a list? In this example, to know how to iterate and count something. All right, I'll put this back on you. How would you use a list to count something? and then be able to refer to it. And this is, I'm challenging you to think about your solution, not criticizing. Just I want you to walk. I can tell you wouldn't get as much out of it as if you walk through it. So walk me through why a list would be a better choice in this example. And how would you utilize a list to do it? Because I remember where you are right now. You're like, well, why K in the context of the Leetcode problem? In the context of the Leetcode problem. Okay, back to the Leetcode problem. Let's look. You're talking about this right here? I just want to make sure before I start answering, I want to make sure I'm answering the correct problem. I want to make sure I'm answering the exact question that you're asking. So the reason why, okay, you can use ordering character instead of dictionary. We tried that. So have you gotten onto Leetcode? So we began to. Now you may have a solution that works. I'm just saying that because you have to associate. So what we did is we were attacking this from an association problem. We're kind of we're mapping ish, but I don't want to use the word mapping because I don't think I'm using mapping to its fullest extent. Now there's probably a way where you can. It's someone who uses mapping a lot. Dir.map. Is it map or mapping? Yeah, map. Okay. So help.map. I know I've used this. I don't think I've readily used it. So this is probably the tool to actually use for this solution. But I wanted to. We have new people joining all the time, so I want to be encouraging, and also I want to solve the problem. So I'm trying to stay versed in problem solving, so when I get a technical interview, I'm not going to have to. I want to be practiced. I want to be I want my skills to be up to speed. And I don't want to go, I want to have something that I have solved recently that I can speak to or refer or something like that, because now I'm approaching 2 months of not having solved real world work problems. But, so mapping would probably work. I don't use it that much. I've maybe used it once or twice, and they're probably coding problem challenges. So with this being references, I can't envision any way to look at a list, because so I did think of the ASCII problem, and I was wondering if it was a cipher shift problem, but first thing I checked was to see if E and A were the same distance from each other as G and D, and they are not. So one is 3 and one is 4. So I was going to take a cipher shift and just shift it over. So how we kind of stumbled into this solution, but I guess I could sit here and try to think about if we took a list. But how would what would be your solve of how we would associate them back and forth? Because the issue is a reference point. And a dictionary is a perfect reference. You take the key and you get a value. So, I mean, if we were to use a list, the only way I can think about doing it is passing in either a list of lists or a tuple, because you have to pair them together and associate them. So we could probably do this the longhand way, and that would be a great practice too. Because the more longer hand way you do this, the more confident and able programmer you become, because you're you're getting more granular with the problem solving. And this right here, understanding the anatomy of an object. So there's a balance between how far deep down do I go, or how much do I allow Python to handle this for us. So I think a dictionary is a collection. It would get in pretty high level, but I think a dictionary right here is a pretty good example. So, Inian, I don't know if that answered your question. I hope it did. And I don't want to detract you from attempting to. I'm not saying don't try to solve it with a list. Please go ahead. I encourage you to, but I also want you. Well, doing it is best. Just try it and see what happens. So, all right. I don't know of a way to speed this up. So, because I want to look at the solutions. Vinky, what was your time on your solution? Because I guess I thought this would capture a lot of them. And then now we're going through, we're taking S and we're comparing T back to it. All right. And that's the most important thing. Get it to work. Don't be hung up on especially if you're trying to get it to work. Do not try to make it efficient while you're trying to get it to work. Get it to work first, and then worry about getting fancy and trying to speed it up and trying to improve it. Because right now, any of us, I mean, even the systems that I was working with Walmart, I mean, we were handing it over to Google Cloud, and it was so optimized, and the data centers were split across the country, and the processing nodes were all right. Okay, I hope that helped. I want to encourage, I don't want to discourage anybody. So when I say how would that work, it's to challenge you, to get you to think. I'm not saying it won't work. There's if you've been around any, you've heard me say there's more than one way to skin a cat, and then I even go one step further. There's 10,000 ways to skin a cat. Here's an example. What? I can get print 3. All right. Len 3. 3. I mean, I can continuously. Are you in the kitchen? My wife is asking why I'm skinning cats. So she's a hoot. She tickles herself. She is a hoot. She's reminding me she's a he's a hoot. She jumped on a live stream a while back, and she was like, hey, just in the chat. So she tickles herself. So, all right. But the point here is to show you there is more. I can get 3 to come out to my screen in a variety of ways. If this problem was to get 3 to come out to the screen 3 times 1, I'm getting 3. Get the solution. And if you're in a position where you do have to worry about optimization, speed it up later. But do not try to optimize it while you're writing it. And if you haven't seen my video about over-engineering, go and watch that. I mean, we talk about that for a minute. And I think I had a photo of a... Hey, Dax, how are you? Oh, Mrs. Sam. Dax says hello, Mrs. Sam. She says hi, Dax. So let's not encourage her to. This will just become more. So, but yes, she is a hoot. I think she's making. Are you making pancakes? She's making muffins right now. Dax, that's funny, Mrs. Sam. Oh, I told her about the peanut butter and jelly thing yesterday. That was funny. She just kind of looked at me, and I was like, "That's funny." So, yeah. So anything pressing, anything else pressing? because I kind of want to look and see. So we're going all the way through. So what's slowing this down? So what's slowing this down is we are touching all of this. We're touching it once, twice, and then we're iterating all the way through. So one of the other solutions are probably only going through if did I show time complexity? Let me show this time complexity chart. Let me grab this again. And then we'll look at somebody else's solution. Let's bring this over. I think everybody can see this. So, all right. So this is respectable. This, of course, is best. Not going to happen that much. So what happens is the more you go and touch the object, the further on the better and worse on this side. So everything on this side is worse. Let me change. Can I change colors? Red. Should be the other way. Everything under here is better because this is the length of your object. So this is respectable and understood. Everything below here is great. This should be green and this should be red. So, and everything, and when you get to here, this is, I'm somewhere probably inside OX² because I'm touching it once, twice, and a third time because I'm iterating through the entire object. So, all right. And let's see. So we're about to approach 2 hours. So unless there isn't anything, let's actually look at one of the faster ones. Let's see what they're doing. Copy. All right, let's see. This is 19 milliseconds. This is a 19 millisecond solution. This doesn't need to be, we can bring this all the way over. Yeah. All right, so let's see what. So they're breaking. Let's see what they're doing. Okay, first has to be true. So they're taking the len of S and T, which that's redundant because we know it's going to be the same. So what are they doing? They're taking indices of X, indices of T. They're making zero lists. They're making characters, stores index characters in string S. Oh, because it's the constraint up to, but it could be 200, 220. That's interesting. I think Vinky just sent something. Vinky, is this your solution? Is that what time it is? All right, here's Vinky's solution. How fast was this? Okay, so 2.9. Okay, that, and then then you added the else C2 in temp. All right, what was temp? Empty dictionary. C1 in temp. Temp C2 mapping. Mapped. Oh, map is a set. Ooh, all right. So a set. Set is a very powerful tool that removes duplicates. If you're unaware of this, so let's kind of glance at this. Did we have X still? X is this. So now set on X. A's and B's. So it gets rid of all the duplicates. So let's see what Vinky is solving. So then I'll have to think about this. Vinky solutions are very elegant and mapped is the set. So then add. So add is a method associated with set. So if C is not in temp, C1 is not in temp. Okay. So this is the forward and backwards. So Venki is looking as you're going as they're going through, as Venki's going through. If I'm reading this properly and I'm envisioning it in my head, the problem with the first few was having a double. Venki, have you checked about? I didn't yet check on Leetcode. We'll probably submit later. No, I saw your example. So right now I'm looking in chat of Venki's last question. We talked about XOR, and I've not used it. I think I've seen it, but that is a good question. I need to, because it's the flipping of variables. I thought that's what your example was it up here? Hang on, let's scroll. So another perfect example. If you're not, yeah, here we go. So if you're not on Discord, you're missing out on all this awesome stuff that Venki's sharing. So here's the syntax and the swapping of characters. So, right? I believe so. I'll have to try that and see if I can dissect it. All right. So this is a really, really good solution. You said you haven't tried it to see how fast, or we haven't tried the XOR. But I think we'll wrap up today. So we got it to work, and that's step one. And then if you can speed it up, that's step two. But don't try to solve all the problems all at one time. And you've got to become comfortable with these problem solvings, and make sure you understand. I can't say this strongly enough. Make sure you understand the problem that you're attempting to solve. Because if you're going to try to solve a problem and you end up solving the wrong problem, Dax can speak to this. If you don't, you're going to end up over here, and then you're going to try to drag this thing that you've built back to where you had it, and it's just going to get worse and worse and worse and worse. Think about trying to solve a math problem on a piece of paper, and you've written in pencil, and you've erased it 100 times. Just the paper's going to get ripped or torn, or you're going to have smudge marks, and you're not going to be able to read it anymore. You're not going to be able to see it. You're going to forget where you are. You're going to have all these things. Start over. There's going to be a point where you're going to need to start over. So, all right. I think that is a lot for today. We've had, I think, some new people come in and join us, which is absolutely always awesome. So let me copy and see. Let me comment this out, because I want to save. That is, I can't believe I'm about to do that. Boom. 1, 2, 3. 1, 2, 3. And that's not right. Not right. And now let's run this. Let's see if I copied all this right. I still don't get why they're taking an empty string and doing 200, because if it's for this constraint, it's actually, what, 5 times 104 is 520. So I don't get this. But it is what it is. All right, so now let's see if I get the same, because I think Venki's on a different. See, I just ran their code, and I got 46 milliseconds. So it was 3 milliseconds faster than mine, and that is a lot of code, a lot of issues. So that's a lot of extra work for 3 milliseconds. So, all right. Let me double check. 255. 250. Oh, Vinky, I'm lost. 255. What is 255 referencing? First thing that came to mind was 5 times 104. Am I missing something? Okay. All right. Well, if there isn't anything else super pressing, let me make sure we haven't missed anything on Discord. Let me move Discord back over here. I don't know what we're going to do tomorrow. It's usually a surprise when I look the night before I go to bed. That's kind of turned into my my last little thing before I do. The as key of all keys. 255. Really? It's 255. There's 200. Is 0? What's 0? Is it 255 or 256? Hang on. And then 256, 255, because that'd be 256 characters. Right? 255 is the last one, is the last character, but there's 256 of them. Now are we on the same page? Am I following you now? Because it has a 0 index. So if we go, let's do 56, it should throw up, right? No way. $60? Well, now I'm lost because I thought there were how many? Okay, so where's hey, was checking from 0 to 200, thought -1 times 256. That's interesting. I'll have to think about that. I like where you're going with that. Stores index of characters in string. So that, yeah, I don't know. I think this is redundant. But then I don't know how. I wonder if they don't actually get up to the full length. So, all right, because I mean, they were already able to destroy it here and here, which this is so cool. This is actually why I like Leetcode the most, is the edge case testing. That whoever writes these challenges, I don't know if it's the same people who write the challenges that are able to come up with the edge cases, because they are brilliant. So if you want to really, and that's also why I'm doing these challenges, because the edge cases are so inclusive, and that's where you really have to stretch with your thinking, your problem solving, your algorithmic design, not just programming, but I mean, you're driving in your car. All right. There's a wreck at this light. What do I do? Is it shorter to go back the way I came and go an alternate route? Okay, no, I'm third in line of the cars and the cops just got here. All right, they're going to clean this out, get us around and go around. Those are those things. How would you make that decision? How did you explain how you made the decision? So the step is, how am I explaining? This is an explanation. How am I explaining my decision? So if you can't verbalize your explanation of how I made this decision, this is just verbalization of a human algorithmic design. That's it. Do not overcomplicate this. All right. We are at 2:10, so we're going to wrap for today. So thank you everyone for joining us. Let's double check and make sure there's nothing pressing. Make sure you're joining the Discord if you're brand new here today, or if you're on the fence. A lot of communication going on over there. A lot of questions being asked and answered. But thank you everyone for joining today. It is always a pleasure to have everyone here asking very good questions. And we'll just do a new one tomorrow. Bye, everyone. Thanks. Dancing peanut butter. Oh, peanut butter. Oh, I know. I drive them nuts when I bring up peanut butter jelly time. Absolutely. They hate it. They are not, but I do it to annoy them. But all right. Thanks, Dax. Thanks, everyone. I'll see everyone tomorrow. Bye.